Hello students, in the previous session we were talking about the design of interactive models or building an interactive model. Now let us discuss about animating that is animating the models. The meaning of animation. Hope you are familiar with because four different lab programs you have executed so far. Out of four, three of them got a concept called as animation. Recall the first experiment itself, rotating triangle it was, right? It was not a static model. Static model is the one where whenever you execute it, it remains same. The orientation or whatever remains the same. It is called as a static one. But the meaning of animation, it is not the static. Instead, it is updatable at every regular interval. The model gets updated, isn't it? Recall as well as your third and fourth experiments. Very good examples there for animating the interactive program because experiment number 3 and experiment number 4 we have done the mouse menu as well as keyboard interaction, isn't it? Rotating cube it was. Both of them, both the experiments were similar, whereas in the experiment number 3 we have considered the orthographic 3D orthographic view, whereas experiment number 4 we have considered the frustum view, isn't it? Recall your lab experiments if you have any doubt. So just go through these points. Using OpenGL, the programmer can design the interactive program, right? Then programs in which the object are not static, rather they appear to be moving or changing is considered as interactive program. See this statement. What I explained just now, they're telling the same, right? Program in which objects are not just static, rather they appears to be moving continuously, they are updating. It is called as the interactive program. Now consider the following diagram in the mobile view. It is not visible. Just see, now I have changed the view. Yeah, fine, now it is visible. See, a circle, you can see a circle, so a square which is constructed inside the circle by using 4 points, right? Just go through this. Yes, go through this picture. Yeah, here the diagram is. We have taken the 2D pointer, 2D coordinate systems only. As you can see, the pair of values, right, for the 4 different points. Recall our previous discussion, right? We replace x and y by angular displacement value. X as the cosine of the angular displacement, that is cos theta, y as the sin theta, because x represents the horizontal side or x-axis side, right? Earlier we have discussed it. It must be there in your notebook. Please recall this. Okay, if you have any doubt, you ask. X, which represents the horizontal side of it, refer the coordinate system, and y, right? Y is the vertical side, so y is the synonym, or it represents the, we replace the y term by sin theta, right? So 4 different points, its values are given. Instead of x, y, we have taken the pair of values as cos theta followed by sin theta. Hope it is visible, isn't it? If it is not visible, please refer to the PDF what I have shared already. Okay. 4 different point values are considered. One other one, sin theta minus cos theta minus sin theta, both are negative. That means the minus sin theta as well as cos theta. The explanation is given here. Consider a 2D point P of x, y such that x equal to, just go through this explanation. Yeah, this explanation. Consider a 2D point P of x, y such that x equal to cos theta and y equal to sin theta, right? This point would lie on a unit circle regardless of the value of the theta, right? Thus, if we connect the above given 4 points, we get a square which has its center as the origin, isn't it? So The above square can be displayed. It can be displayed as follows. Here the coding part is right. What display we have considered. We are displaying a polygon. Just to go through this, which I am pointing. Okay. GL begin. GL polygon statement is made. Polygon statement is for what? Since you are constructing a square or in general a polygon, right? Here we are converting the degree into radian, because for calculation purpose in OpenGL it takes the standard value or the angular displacement value in terms of radians only. Please remember this. So we are defining the new value, that is theta r is taken, new variable theta r is taken. How theta r is defined? Conversion of the degree into radian. How you are converting the degree to the radian? 5 by 180 you are considering, isn't it? So that is what we are doing. So theta by 3.14159, that is 5 by 180. Here it converts the degree into radian. Go through the comment line. Fine. Now you have to consider four different vertices, whereas each vertex is nothing but a pair of value, x coordinate value followed by y coordinate value. Okay. Now don't mention cos of theta, instead please remember mention cos of theta r. Okay. GL vertex 2f, since it is a two-dimensional coordinate system. F because real values to be taken, since floating point values to be taken, because fractional values we have already considered here, that pi and all comes over. So 2f is written. Cos of instead, yeah, 2f is written instead of 2i. Cos of theta r, earlier it was cos of this point we are writing cos of theta, as you can see, cos of theta comma sine of theta, isn't it? So theta is converted to theta r now in the above step. Cos of theta r is taken, sine of theta r is taken. Repeat the same step, that is GL vertex, plotting the vertex. Next 3 points you have to consider, list out here: sine of theta r comma cos of theta r minus cos of theta r minus sine of theta r, and so on. Okay. And once the value of theta, that is the angular displacement value, is changed, what will happen? Recall your spin cube program. Once the angular displacement, the angle is updated, model will be updated, isn't it? Same thing is explained here, right? Suppose, yeah, just go through these statements. Suppose that we change the value of theta as the program is running, the square is nothing but the model what you have constructed appears to be rotating about the origin. If the value of theta is to be changed by a fixed amount, whenever nothing else is happening, then you have to make a call for the idle function. It is exactly same. Please recall, it is exactly same as that of our spin cube program. Spin cube program, what we are doing in spin cube? In spin cube, we are making a call for the idle function, glut idle function of spin cube. Please recall that lab program experiment number 3. Okay, glut idle function of spin cube. What spin cube function does is, every time it is updating the angle theta, right? Theta equal theta plus 1.0. Once it crosses 360, we are resetting its value, that is we are starting from 1. Please go through the spin cube module as well as the main function. In the main function, when nothing is happening, for the first time, whenever the object is being displayed, what we are doing? We are doing a callback for the idle function, where you have to rotate the model about the origin, right? And whenever you want to, even we have taken the example of pause, that 3 different options we have considered, like x-axis rotation, y-axis rotation, as well as z-axis rotation. Then even you have considered the option for pausing the model, isn't it? Whenever you want to pause or stop the rotation, then what you are supposed to do? You have to uh, pass the parameter. In place of idle function callback, you have to pass the parameter to 0. Instead of making call for spin cube, what you are supposed to do? You have to just mention 0, where it stops the angular updation, right? Please recall the experiment number 3. It is almost the same as that of experiment. If you understand that, then easily you can understand these concepts, right? Fine. The coding part, as you can see, void idle, what we are doing, we are updating the value of theta. How? Just check here, void idle function. How we have done earlier in the same way. Earlier we have updated it to 0.1, 0.2 and 1.0 and so on. If you want to increase the speed of the rotation, you have to increase the value here, angular displacement value. If you want to reduce its speed of rotation, then you have to reduce the value of the angle what you are mentioning. Okay, so as per this example, void idle, you have to update the value of theta. Okay, theta equal to theta plus 2 we are doing, that is shorthand operator is used. Theta plus equal to 2 is written. Once it crosses 360, what you are supposed to do, you have to reset the angle to 0, that is theta equal to theta minus 360. Again it start from 1, 2 degrees, 3 degree and so on. Once a complete rotation, once a 360 rotation is completed. Glut post redisplay, this is to bring the model, updated model onto the display. Whenever the angular displacement is added, bring the model or display the model onto the monitor. Fine. Okay. Now see, the above idle callback function must be registered in the main function. The same thing what we have discussed earlier, glut idle function followed by name of the function. Here the name of the function we have taken is idle. As you can see, void idle is written. Hope it is visible. Check the pointer which I am pointing. Void idle is taken. As per our lab experiment, we have considered it as void spin cube. In that case, glut idle function of spin cube we have called, here we have called the, since we have written the user defined function as idle, so callback for the idle should be registered. That's it, isn't it? We can further implement the mouse, keyboard, as well as we can even have the menu concept. Please refer my previous video as well as our lab experiment, since we have done all the three different types of inputs. That is, we have implemented mouse, keyboard, as well as we have developed the menu for the experiment number 3 as well as 4 what you have executed. If you have any doubt, you ask. Let us continue our discussion in the next session. Thanks for watching.